Hello, this is Clint Halstead, and this is an internet course entitled Introduction to Microprocessors. I'm using a book called Designing Embedded Systems with PIC Microcontrollers, Principles and Applications, 2nd edition by Tim Wilmshurst. And in previous lessons, I've discussed hardware, the different types of hardware that you need. We talked about the PIC16, PIC16, and we talked about some PCB board hardware that you need to design a microcontroller project. And then we talked a little bit about assembly language. I gave 6 basic instructions. And now, before we can actually start to code or write the assembly language code for a PIC16 processor, we're going to need to have some software. So in order to get the software, you can download it for free from Microsoft. Just go to Google and type MPLABX and click enter. It'll bring you to Microchip's website. You can download MPLAB free for here. And then once you download that, I would recommend downloading also the C compiler as well. After the tool, after the tool installs, you can say click a button check mark to install the C compiler. So once you get the MPLABX icon, then you can double click on that icon. And what we're going to do today is this is going to be like a basic tutorial of how to use MPLABX, and also it's going to be included in that is going to be how to write your first assembler language program using a PIC16 microprocessor, and we're going to use the PIC16 F84A, and then we're also going to simulate that to debug it. Okay, so that's basically what we're going to do right off the bat. Okay. So when you open up the tool for the first time, the way you start a new project is you say create new project, or you can go up here and say file new project. Either way is the same. So let's just do create new project. Click on that button right there, create new project. Now for our first project, we're going to do, if you have an existing MPLAB older project, then you can do there pre-built text file or library. We're going to do the standalone project because this is a brand new project. Now we can just browse through all these devices. There's hundreds of devices, or we can simplify it a little bit. We can tell it that we want either the baseline, the mid-range, or the advanced. So we're going to use the mid-range because that's a part of the PIC16 F84. That's what family it's in. So we just go down here to PIC16F. This should be in alphabetical order, 84A, and then click next. This tells you all the tools you have. We do have a PIC3 because we're going to use MPLAB later, but for this lesson, we're not going to use any hardware at all. We're just going to use the software tools. So you don't need any hardware to do this lab. So we're just going to select simulator because we're just going to use the computer simulator. Now it already knows what tools I have installed. I installed the MP assembler, and when I download the tool, that came automatically. I didn't have to really do anything. But if you install the C compiler, then you also get the XC compiler here. But since we're not programming in C today, we're going to be using the assembly compiler. So you need to click on this MPASM. That's the microchip assembler. And we'll click next. Then you just need to call it a project name. So let's just call it, we'll just call it first project. Call it first project. Notice you can change the directory location. I'm just going to put it in users Clint MPLAB. So if that's where you want to put it, then just click finish, and it will create your project. So now it's created a project. You can't really tell any difference right at this point, but what we're going to do is, this is all your project files over here. So the first thing we want to do is we want to create our new source file. Okay. So what we're going to do is File, Open Project, Open project. Alright. I don't know why it had that file in there because I didn't create that file. Anyway, what we're going to do is on the source file, we're going to right click and say new. And when I first opened the program, it did not have an option for assembly file. It just said empty file, C file. I had to go to other, and then I had to click assembler, and then I had to click assembler file. So we're going to do it that way. And then after you do that for the first time, then it'll actually put it up on the program list for you. So let me just show you that one more time. Let me just cancel that. I went a little bit fast there. So it's for source files, say new, and at first that will not be there, so you say other, and then in the categories you click down on assembler. So you can program in BASIC if you want, C, but we're going to do assembler. So let's do assembly file, and then we click next. We're going to put it in first project. I don't know why it keeps trying to put it in this old project. This was my old project. We want to put it in first project. In fact, I just noticed something. This is not right. Up here. First project. Yeah. Yeah. File. Close. Project. Close project. Okay, so notice that I had to close out those projects. I had an old project in there, and for some reason I just had to flush it out. So I'm just going to continue on. I'm going to kind of start that over. Let's open up my new project that I created. Okay, so I think what happens is once you start a project, once you open the tool, it kind of remembers where you're at the last time, so that may be a source of confusion. So I closed out all the projects. I'm going to open, this was the first project I created. It's called ELN 232 Project Example 4.2. But then I just created a new one called First Project. I'm going to open that project. Okay. So I'm going to kind of start over. Okay, so let's start over again. Source files, new, okay, other, and then we're going to go to assembler, assembly file, and then next. And then the name of the file, I'm just going to call it first, let's just call it first _ prog. And extension, we're going to give it ASM. And you can click set this extension as default. That's what I would do. I've already done that, but notice if you do that, then you can say set this extension as default. But since I already did that the first time I used the program, it's grayed out now. So now it should be set up. We want to call the extension .asm just to make it easier, and then we'll just say finish. And then it's kind of nice because now my file's over here. I can see, actually, if I click back on project here, it'll bring me back to my project. And now I can see that under the source files I have this first project.asm, and it opened up over here on this side as well. Notice when I click over here, then this goes to a different menu, but if I want to get back, then I can just click on the projects again to take me back to all my project files. But let's stay right here for now. So what we want to do is we want to enter in a first program. We're going to use a program in the textbook called Program Example 4.1 on page 84. So what we're going to do is, the first thing we're going to do is we're going to make sure we're starting on the first line, and we're going to just make a comment line. Okay, so this will be our first comment, and then we're to say, remember that the semicolon tells you that it's a comment. So this is not going to affect the program. We're just going to document some things. So this is going to say very first program. And then I'll make another comment. This program repeatedly adds a number to the working register. So that's what we want to do. And then I'm just going to put my initials and then today's date. And I'm going to put another bunch of asterisks. That's usually what people do. Kind of make it inside of a box, and then I'll say use the org directive to force program start at reset vector. Okay, so that's just a comment on the next line. So the next line is going to be the org statement. Now notice here what I'm going to do. I'm going to tab over twice. The reason is I don't want, if I start typing here, if I type org there, it's going to make that a label. But I want it to be, I don't want it to be considered a label. Actually, it looks like, notice how that the tool, it's kind of neat because the tool will recognize, it'll put anything in green that's a comment. Now, if I mistype that, if I type vorg, which is incorrect, then it recognizes that it's wrong and it actually calls it, it makes it a label. But since this is a reserved command, it highlights it in blue. So that means it's a reserved command. But so I could technically probably put it there in the first line, but I'm not going to do that. Just for safety, I'm going to put it over there. So this guarantees that the program is going to start in the flash memory at address location 0. That's what the org command means. Okay. So next, I'm going to put another comment. I'm going to say program starts here. Then I'm going to tab twice and then start my code. So clear W, that's the command. That's one of the commands we learned. And then I'm going to comment over. I'm going to say this will clear the W register. Now notice how my comment is green. So the editor here noticed by when I put the, as soon as I put the semicolon, that I was going to have a comment. And clear W turned to dark blue, which means it's an instruction, a recognized instruction. So it's really, really nice that that we have that. Okay. Now, what's the next line going to be? Well, next we're going to put a label called loop. I'm going to tab over. We'll go add literal to W 08, and I'm assuming the default radix is set to probably hex, but it wouldn't really matter. Even if it was decimal, it'd still be 8. So then I'm going to put a comment, add the number 8 to W register. Now I'm going to tab over and say go to loop, and then hit enter, tab over once, and then say end. That's it. Oh well, I guess I should comment this and say, well, no, that's pretty obvious. That's an end. You can put a comment there like the book does, but I think it's pretty obvious. So I'm just going to click save up here on the top left. Save my code. Now, this is pretty easy. I mean, so far this has been pretty easy to use. I'm going to actually go back to my projects here. Okay. Go back to my navigator. Okay. And I'm going to hit the project build. If you see down here, you can see that it is building the project. And let's see, error 0 is all the information here. You can see it says loading completed, so it looks like it's done. Now, one thing I wanted to show you is, let's go to the window menu, click window, and you can go to, let's see, output, and then go to the disassembly listing file. And we want to look at the listing file. We talked a little about a .lst file. Let's look and see what those .lst files look like. Okay, so if we click this, this is kind of neat. It's a file that shows you what your code is going to look like in memory. So over here is your code as you typed it, and it kind of tells you every line number in your Word document. So 1 through 15. I guess I had some spaces down here. But this is not the way that the program shows up in actual memory. There's only 1, 2, 3 lines of code. There's only 3 lines of code. All the rest of the stuff is assembler directives and comments. So actually these are the only 3 lines that are going to show up in your flash memory. Address location 0, this is the machine language. 0103 hex is the clear W command. So this is actually the only, this line, and this line are the only things that's actually going to show up in memory. And these numbers over here just show you the location in the memory, the address location. So this is the only thing that's going to actually be programmed into the flash. The rest of this stuff is just for information. This is information, this is information. So that's kind of a neat thing to see. And then you can click the little X button up here. Notice at the top of the page also you have these little tabs, so you can go back and forth between different things that pop up, and then you can close them if you want. Okay, so that's the first thing. We wanted to make sure that you see that you can go to the listing file. Now, let's just go ahead and debug this project. Let's just assume that we just want to simulate this and see if it does what we want it to do. So it's pretty easy to do. All you have to do is click Debug Project. Click this button here, and it'll start running it. It's actually running right now. If you want to stop it, but you can't really see what's going on, so you stop it, and it stops in the middle of this code. But we're not able to really view anything. So let's go up to Window and go up to PIC memory views. Okay, so we want to see inside of the processor. So we want to see the special. Let's just say that we want to see the special function registers. We could also look at the program memory, but let's look at the special function register. You can see here the W register, the status register, port A. So you get to see Trist A and B. If you put your cursor over them, it shows you what the decoding of those, what they actually mean. Really neat. Also, you could also go up here and say PIC memory views. You could look at the program memory. So this is actually what's in the program memory. There's your code right there. Clear W, add literal to W, and then go to, and then there's the loop. So that's address 012. So that's kind of neat. You can close this out if you want it. You can go down here and you can click on the tabs, or you can close things out if you want to close them out. Let's go up to file registers. Let's say we want to look at file registers. We haven't really used the file registers yet, but if you want to look at those, then they're right here. Okay, let's close that out. Window, PIC memory views. You also have EE data and other memory. So for right now, all we really care about is the special function register, so we're there. Now, in order for us to really step through this code, we want to step line through this code. Also, I want to reset, because this code was running just back and forth, and this random value just wound up in memory. So let's see if we can reset this. The way to do that is instead of clicking here, you have to click on the little triangle and say Launch Debugger instead of Debug Project. I don't really know what the purpose of that is, but Launch Debugger is going to give us our little menu button, our ability to step through the code. We can look at the different things we have. We have stop, we have reset, we have run basically, or continue. This is like a go or start button. We have step over, step into, run to cursor, set PC at cursor. So we have all these different things. Well, what we're going to want to do is just reset it to the beginning. Okay. Also, down here, let's go back to our special function register. Once we reset it, notice that the program counter goes to 0, W register goes to 0, your status register goes to 26. So first thing we're going to do, we want to single step through it. So we want to step from this first instruction to the next one. So let's hit step into. Okay, that's going to just step into the next instruction. Okay, so increment to the next instruction. The program counter went to 1. The program counter is what keeps track of what instruction you're on. So this is instruction 1. Okay, so it cleared W. So the W register was cleared. Now we're on the green instruction. The green instruction hasn't really executed yet. So let's execute that single instruction by doing step into. Now notice that as soon as we click that, the W register went to 8. Okay, that's what it was supposed to do. It took 0 and added it to 8. Now we're going to click step into again, and it's going to loop back. Okay, so hit loop, and it says go to loop, so it went to loop. Then we're going to single step again. Now look what happened. It added 8 to 8, because it's adding literal to W. It's adding the value of 8 to whatever was in the W register. Well, there's already 8 there, so it added 8 to 8 and give you 16. So if we continue to step through this code like this, you can see it went to 24, 32, 40. We can continue to step through here. 72, 80, 88, 96, 104, 120, 136. Just continue to step through here. We're going to see what happens, because this is only an 8-bit number, so we're going to wonder what's going to happen when the number gets full. Notice here that it has both the hex and decimal equivalent, so it's F0 is equal to 240 decimal. Okay, now we got F8, which is 248. Now this is an 8-bit number, and so it only goes to 256, and we're already at 248. So let's see what's going to happen on the last one here. Oh, okay, it goes all the way to 0. So it overflowed that register, so it just kept adding and just overflowed. So now it went back to 0. So now if we keep stepping, it's just going to keep doing the same thing. So it's just going to repeat forever. So that is an introduction to MPLABX, starting a new project, writing a simple assembly language program, and then simulating that with the MPLAB simulator tool. Thank you very much, and next time we're going to the next tutorial we're going to actually do a more advanced program that's actually that we're going to be able to load in the hardware. So thank you very much.